Hi, my name is Elijah, and this is Trust. This is our senior design showcase. Our project this year was the holographic type video conferencing system design. I'd like to talk a little bit more about that. So, of course, this is through our University of Nebraska-Lincoln, and we really wanted to learn more about things like computer vision, mixed reality, and reconstructing those things in a 3D environment. Of course, our sponsor throughout this year is Dr. Guo. And this project was primarily his idea, so he has been working with us through all these things through this past year. As well as that, we have our faculty, staff, and coach, our project manager, Melanie Kugler-Wright, our tribe lead, Dr. Shruti Bowman, and our industry coach, Dr. Saya Kun.
And then I'll just talk about us a little bit. We were originally comprised of 6 people. One of them ended up going to a different project. So we had 5 of us this year. That was comprised of Priyanka and Grant, which they were both our squad lead, product manager, and development manager. We got Eli here, Leo, who couldn't make it here today, and then myself. Leo is software engineering, Priyanka, electrical engineering and data science, and the rest of us are computer science. We come from different backgrounds, but this was an exciting project, and I'll lead into that. The problem is traditional video conferencing is not really immersive. It's just a 2D flat surface, and we're hoping that with this project we could find a potentially more immersive environment or experience. And lots of ways you can do this is in regards for teaching. And we thought that's like a good kind of example for what the future holds for this kind of technology that we worked on. For our opportunity, what we wanted to do to make it more immersive was essentially construct like a 3D hologram instead of just a flat 2D surface. And to do that, you also have to be able to stream it in real time. And we're going to look at using computer vision plus some deep learning or machine learning models. And luckily, for our solution, Dr. Guo, he does teach machine learning, had him in class, and he actually, before we started on this project, we had one thing to work off really, which was a machine learning model that he had for these Intel RealSense cameras. And I'll go into that a little bit more here. So for our solution, we are comprised of a few different cameras. And what they do is they capture color, but they also capture depth with some infrared laser. And that comes in handy because we need to construct a 3D object. So having that depth enables us to kind of capture where it is on the XYZ plane. And then while we capture that data from a camera, we want to be able to present that so people can use that model, or rather we need to construct a model so people can see it inside the video conferencing software. And then in regards to processing, we found a way using his machine learning model. We built off of it a little bit, and we found a way to transmit that into certain software that allows us to view it on a Microsoft HoloLens 2, which is very nice because it's very immersive with your environment. You have virtual reality, but augmented reality helps us use our environment and act like it's part of the environment. And there was throughout the project it was a little tricky, but what we decided to do was we took that script from Dr. Guo, we kind of altered it a little bit, and with his script, it would capture the different point cloud, which is kind of a representational 3D object, you could say, to make one point of our hologram. So when we see a hologram, it's comprised of multiple different points, which we call point clouds. And using his script and some libraries with the Intel RealSense cameras, we're able to use some models that he had in his script to write an extrinsic file. So yes, using one camera is really possible with the depth too, because it has the infrared laser. What we want to do is we want to capture more of the image though, so it's more immersive. So yes, using that Python script, we are able to get an extrinsic file. And then once we use that extrinsic file, we load it up into our Unity project. And inside of Unity, luckily, there's a way you can holographically remote onto the HoloLens 2, which is really, really convenient because we would have had to use probably some more complex networking stuff inside of there. And yeah, so inside of our Unity scene, we have objects for each point cloud stream. And once again, luckily, with the Intel RealSense SDK, which we use to capture a lot of that data from those cameras, we're essentially using a wrapper, which we import into our project, so we don't have to call those C++ libraries explicitly. And doing that, we're able to, for each of those objects, stream in that data. And using the extrinsic file too, we're automatically adjusting the alignment from each of those cameras to better mesh or make one cohesive object, really. So yeah, that's our product solution that we had. The value and highlights were really great. As you can see, like in this photo here, these are individual point clouds, so it's a little bit easier to like see what I'm talking about. The technical value is great. It brings real-time 3D hologram generation. It's, like I said, it's streaming in color and the depth from those cameras and a live streaming session. And then for system design-wise, we want to make it a little bit scalable. We are initially going to use a machine learning model and put it in between streaming it, but it just adds too much latency. So that's why we calibrate that initially at the beginning, and then we go ahead and we pull from that data and just automatically readjust inside of our Unity scene, so we're not applying that every single time it grabs some data. And then the impact. So this is there's not a lot of coverage over this kind of technology out there, so this is pretty cool to be able to use point cloud, and you can use Unity, Unity was a great source of software that we've never used before as a group. So it was great to be able to get into there. As well, like I said, the point cloud stuff. We've never really touched open source SDKs and stuff like that. So luckily we got experience grabbing open source software, using it for our own, and seeing how we could transfigure the SDK itself, which we did. There was a couple points in the wrapper where we edited the SDK itself so we could allow for multiple streams of data from all of those USBs. But it's going to support obviously a lot more research into that area and how we can go ahead and maybe get a full 360-degree angle of a hologram. But yeah, it's just a really great project that we got to work on that brought a lot of light into different types of software, hardware and software related. But yeah, we had a lot of fun on this project. All of us come from different backgrounds too. It's just really great to work into. And that's it for right now. Thank you guys. We're really grateful to be able to work onto this project. And I don't know if you want to say anything, Eli.
I'd say this was a very uniquely challenging experience for us, just because, like Tress was talking about, the background, all the software we were using, none of us had a background with that, so it took us a little bit to get going just because we had a learning curve. And also, I think something that's unique to us is nobody, I'd say, really uses HoloLens, just because I think it is ending. I think it might be discontinued.
Yeah, it got discontinued a bit. Yeah.
And some of the RealSense cameras are also outdated, but that was actually unique for us to figure out, okay, how can we take old technology that maybe people don't use as much, that maybe isn't the modern standard, and being able to implement that for this design now, but also be able to give that as feedback to Dr. Guo to be like, hey, maybe this is something in the future, maybe we use something else, but we know that this is something that works on maybe equipment that isn't the best, and being able to put it on something better.